Today I am going to discuss something about what the synchronous impedance, how the synchronous impedance is important to us for a synchronous machine, for finding the various performance of a synchronous machine. What are the methods which involves in finding the synchronous impedance? So let's start the topic. Topic is to find out the synchronous impedance for a synchronous machine. So before finding the synchronous impedance, we need to go through what the three more tests like DC resistance test, open circuit test and short circuit test. These tests are very necessary for find out the performance of exact performance of the synchronous machine. So first of all, I am taking what the DC resistance test. We need to arrange the machine such as represented in schematic diagram. So have you seen that this the field winding of that machine is going to be open circuited, and we need to apply the voltmeter across the two phases and ammeter at one phases. Now because the third phase of that synchronous alternator is open circuited, for that purpose the voltmeter is going to measure the voltage across the two windings which are connected in series, or ammeter is going to measure the current flowing through this winding. So in that sense we have supplied the DC supply. So on the occurrence of the DC supply we have the flow of current. That current is going to measured by this ammeter, and that voltage potential difference between the two coil will be going to measured by the voltmeter. So when we have the voltage difference between the two, this is supposed to be the line voltage, and the line current is that the meter is going to measure. So when we apply the formula by Ohm's law, that means impedance is equal to the voltage upon the current potential difference across the circuit divided by the current flowing through the circuit, we will be having the resistance that will be DC because we have supplied the DC supply. So in that sense we can calculate the voltage upon current ratio, that is what nothing but the DC resistance. So it is what the first test is called the DC resistance test. Thank you. What the second test, which is called the OC test or open circuit test. In this test the circuit element is like represented in a symmetric diagram. You can see that in field winding we have applied the DC supply. Ammeter is going to be connected to measure the field current IF. RF is the winding resistance, and DC supply is what the input to the field winding. Now we have arranged the voltmeter in such a manner that it is going to represent or measure the each and every line voltage. So it is what the L1, L2 lines are there. We have connected the voltmeter between L1 and L3. We have also connected the voltmeter between L2 and L3, and also between L1 and L2. So that is what the arrangement of this type of test. Now when we are going to increase what is OCC? Actually OCC is nothing but that is a test which represents the variation of open circuit voltages with respect to the field current. It is what the short circuit test. In short circuit test, the circuit element is as shown in figure. We have the field winding, we have the armature winding. Armature winding is going to be short circuited, and field winding we have to apply the DC supply. Now ammeter is going to be connected for measuring the field current across the field winding, and three respective meters are connected with the phases to measure the armature current, so which is short circuited. Now what is this short circuit characteristic? It is nothing but the variation of IF, IA with respect to the IF. So when IF, the field current is going to be 0, the IA is certainly be equal to 0. As you increase the field current, the IA is going to be increased in a linear fashion. That straight line which is plotted with as a variation of IA with respect to IF is called the short circuit characteristic or SSC. So it is all about the short circuit test. Thank you very much. Using these three characteristics like DC resistance characteristic, short circuit characteristic and open circuit characteristic. So for finding this we need to draw all the characteristic on a same graph. That means we need to draw the SSC and OCC with respect to the variation of EOC and IF. So we need to draw in all the characteristic in an axis in which we have the IF variation, and on the IF variation what is the variation of EOC. So certainly the SSC is going to be the straight line as we have seen in last sections, and the OCC is going to be a straight line up to some region, that means from O to B, and beyond B is going to be saturated, so it is get the parabolic nature. Now when you draw the SSC characteristic, that means when you find out the SSC value, it is going to be intersected the SSC characteristic on C point. So the synchronous impedance can be find out with the basic relation given by the ohms. The impedance is nothing but voltage upon current. So when you take the voltage when it is open circuited, the system is open circuited with respect to the current when the system is short circuited on per phase value, that is going to give the synchronous impedance value for you. So in simple manner, when ZS is equal to OCC voltage per phase basis divided by short circuit characteristic per phase basis. When you, how to find out these value? So these value can be find out with the help of graph itself. When you draw these type of characteristic on a same baseline, so it is going to be in according to this graph which I have represented. It is what the OCC value is going to be AB, and whereas the short circuit current is going to be AC. So the ratio of AB and AC is going to give you synchronous impedance. Another, we have the important thing we need to discuss here, that what is synchronous impedance. As you know, the synchronous impedance is what the armature reactance plus J times, that means the complex operator times the synchronous reactance. So why I'm emphasizing on this? Because in many numericals we need to ask find out something about the synchronous reactance. We can find out RA with the help of DC resistance test, and we need to find out the ZS, and by using ZS value and XS RA value we need to ultimately find out the XS. So when we find out RA with the help of armature DC resistance test, and ZS can be found out with the help of AB by AC by drawing these following three characteristic, then ultimately XS will be equal to ZS square minus RA square within under root square root. So that is how we can find out synchronous impedance. Thank you very much.